Welcome to our second video presentation on weathering and mass movement. In our previous video, we focused on concepts relating to weathering. We looked at briefly on the different types of weathering and focused primarily on physical weathering. Now for this presentation, we are going to focus primarily on chemical weathering. Now, as the concept suggests, chemical weathering, rocks are broken down due to chemical changes in the minerals that make up that rock. What are these processes that we're talking about? We're talking about oxidation, solution, carbonation, and hydrolysis. Please note that one process may not occur independently, but there may be a combination of different types of chemical weathering. For example, solution may be combined with carbonation in order to cause that rock to break down. All right, let us start with oxidation. Now, when minerals in a rock react with oxygen, that process takes place. For example, iron may combine with oxygen, forming either ferrous iron oxide or ferric iron oxide. This causes the rock to weaken in structure and eventually break up. Now, this process is known as rusting. Similar to when we leave metal outside for a long period of time, we find that when we go back and we touch the metal, we realize that particles from the metal start to break down, result weakening that metal. That process is known as rusting. It is similar to that process we call oxidation. Now, secondly, solution, as the name suggests, minerals are combining with water. Now, some rocks contain minerals that we would call water soluble, and therefore these minerals can be dissolved in the water, weakening rock structures, eventually resulting in the breakdown of rock. For example, minerals such as calcium carbonate and rock salt may be broken down in this way. The third process we're looking at is carbonation. And carbonation is responsible for the breakdown of limestone rocks in limestone areas. This is because rainwater or groundwater absorbs carbon dioxide from the atmosphere. This creates a weak acidic solution, which dissolves the calcium-based rocks such as limestone, resulting in those features that we find in limestone areas such as stalactites, stalagmites, the formation of caves, pillars. Now, the last process here, hydrolysis, it's simply saying minerals are reacting chemically with water. So this process, hydrolysis, solution will be a type of hydrolysis and carbonation a type of hydrolysis because here we have minerals reacting with water. Now let us look at the third and final type of weathering, which is biological weathering, also known as biotic weathering. As the name suggests, bio, we're talking about living things. Now, how do plants and animals contribute to weathering? Now, there are some animals that we would refer to as boring animals, such as rabbits, sand martins, right? They bore holes into rocks, resulting in the breakdown of rocks. Also, roots of plants may force their way into cracks or joints in rocks. And as the plant grows, eventually it will cause the rock to break apart. So this is how we have plants and animals contributing to weathering. Now, how does climate influence the rate at which weathering takes place? When we looked at, in our previous video, we looked at freeze-thaw or frost action, we realized that this type of weathering would not take place in the Caribbean because our temperature does not fluctuate around 0 degrees. So for some types of weathering, we'll find that they are mostly in some climatic areas. In cold climates, frost action would be more prevalent, as there is a wide daily range of temperature, or at nights it may fall below freezing point. So we'll have frost action taking place only in those climatic areas. Now, rainfall is important for chemical weathering to take place. So we find that in climates where there is a high amount of rainfall throughout the year, you would have more chemical weathering taking place. Now, chemical weathering takes place at a slower rate in low temperatures and takes place at a fast rate in warm and moist climatic conditions such as the Caribbean. Now, how does the type of rock influence weathering or the rate at which weathering takes place? Now, for the different rock types, we know that we have igneous, sedimentary, and metamorphic. So therefore, would be more resistant than others. So the more resistant rocks would be weathered slower than the ones that are less resistant, right? Now, there are some rocks too that are highly permeable, meaning that water can easily pass through. So, for example, limestone rocks are considered highly permeable. So, we find that these types of rock with a high porosity or high permeability would be weathered easier or faster than other rocks. Some minerals found in rocks are more resistant to chemical weathering. So, for example, the mineral quartz, they are resistant to chemical weathering. So you'll find that the rate at which weathering takes place would be slower. In comparison to other minerals such as feldspar, they are weathered easily due to the process of hydrolysis that helps to alter the chemical composition of that rock, resulting in its easy breakdown. Now, also, we find that some rocks have more joints and cracks than others. These rocks would be weathered easier than rocks with fewer joints and cracks, or rocks with no joints or cracks. So, this is how rock type can influence weathering or the rate at which weathering takes place.